Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. My name is Samirul Hazimin Roslin and my metric cards number is 2019438248. For today, our experiment is the observation on the microstructure of the cast iron. So, the objective of this experiment is actually to study the microstructure of cast iron using the optical microscope. Then, is to discover the classification of cast iron based on the characteristic of the obtained microstructures. The apparatus we will be using first a computer and then an optical microscope and for unidentified sample of cast iron. Firstly, open isolation light on your computer and then click on the image capture on the left side of the interface. Once the image capture interface has appeared, click on Live Measure on the right side of the interface. Thirdly, put sample and the magnification lens on the workstage. Please use the light as your position reference. Fourth is adjust the coarse focus slowly until the sample close to the magnification lens. Be careful when adjusting the coarse so that sample won't hit your lens. On the fifth is adjust the optical lens according to your eyes until the image is quite clear. Then adjust the coarse focus slowly until the image of the sample appear on the computer interface. Then adjust focus by using the fine focus dial so sample image appear clearly on the computer. Rotate magnification lens to zoom in and zoom out. But do not hold the magnification lens body. Instead, use the magnification lens holder to rotate. Lastly, continue observation with all other samples and switch off microscope and computer after finish. So the first result under the microscope is ductile nodular cast iron. As you can see, the dark spot is actually graphite nodules, also known as spherical light. So dark graphite nodules in a alpha ferrite matrix. second result we have is white cast iron. The dark spot is pearlite, while the light region cementite. And then thirdly, we have grey cast iron. So the dark kind of like line or worm is actually graphite flakes. The white region is actually alpha ferrite matrix. Graphite flake shows the fracture of the surface. Lastly, we have malleable cast iron. But the dark spot is graphite rosettes. So it is actually similar to the nodular, but nodular graphite is or sapphire, but malleable graphite is not sapphire. It doesn't have that like consistent shape. The light region is alpha ferrite matrix. Discussion 1. Carbon steel work and cast iron work. Compared to the carbon percentage is the steel work contains not more than 2 weight% of carbon. On the other hand, cast iron usually contains around 2 weight% to 3.5 weight% of carbon. The next is hardness. Steel work is not as hard and strong as cast iron, but it's actually tougher, while cast iron is harder and stronger than steel, but it is brittle, which means it's not quite tough. Number 2. Gray cast iron has a graphite microstructure. The matrix includes graphite in the form of flakes. This gives way to poorer metal regions. It also has a poor tensile strength. This is because the stress accumulation at the tip of the graphite flakes, making them brittle in nature. Number 3. Compare white and nodular cast iron with respect to composition, microstructure, and mechanical properties. Firstly, I will be talking about white cast iron. So the composition of white cast iron is it has around 2.5 weight% to 4.0 weight% carbon and less than 1% of silicon. It will produce a perlite and cement type microstructure because of rapid cooling. And lastly, the mechanical characteristic is it's actually hard, high compressive strength, high strength, brittle, not weldable compared to gray cast iron, becomes malleable cast iron after annealed, and then difficult to machine. And lastly, fracture surface. Next is nodular cast iron. The composition for nodular cast iron is magnesium or cerium is applied to the gray cast iron composition before casting occurs. This is to prevent the graphite flakes from developing during slow cooling of the iron. And then the microstructure is spherical like graphite structure in perlite of ferritic matrix or nodular. The mechanical characteristic is high ductility, elastic modulus, mechanical strength, corrosion resistance, and it's low cost and it's actually easy to use. I can conclude that all of the objectives have been achieved. The first result we receive is nodular or spherical like graphite structure in perlite or ferritic matrix. This we can classify as ductile nodular cast iron. And the second result is perlite and cementite. We can classify this as white cast iron. So the third is a alpha ferrite or perlite matrix surrounding graphite flakes. We can classify this as gray cast iron. And the lastly is rosette of graphite surrounded by ferrite or perlite matrix, and this also can be classified as malleable cast iron. The apparatus we were using in this experiment was a computer, an optical microscope, and a few samples of cast iron. So the procedure is firstly opening ice solution light on the computer, and then put a sample on the workstation using the light as reference. And then third is adjusting the coarse focus slowly until the sample is near to the magnification lens. Then adjust the optical lens according to our eyes, adjusting the coarse focus until it appears on the screen interface. Then using the focus dial to make the sample image clearer on the computer interface. And then rotate the magnification lens to zoom in and zoom out. And lastly, repeat the same step with all other samples.